Hello everyone, you're welcome to my class. This is a continuation of our last class. We stopped at question 7. Today we are going to continue from there, which is question 8. So question 8 says, state one similarity between a capacitor and an inductor. So we're looking at question 8a. The similarity, that's something that is common between inductor and capacitor. So capacitor and inductor, we have both capacitor and inductor are used to store energy. You have gotten your answer and you have your mark. So if it is differences, capacitor stored energy in an electric field, right? While this is L, while inductor stores energy in a magnetic field. So this is the differences. Although this particular question here asks us for the similarity, which is this. This is your answer to that one. But in case you see you asked to state the differences. So one of the differences is that capacitor stored energy in electric field, while inductor stored energy in a magnetic field. I hope that is understood. So we have question 8b. So question 8b says, an electron projected into a magnetic field with a velocity of 3 exponential 8 meters per second at an angle of 60 degrees to the field experience a force of 6.23 times 10 raised to the power minus 1 Newton. Calculate the magnetic flux density of the field, given that the electron or the charge is 1.6 exponential minus 19 coulomb. Right? This is one of the simplest questions also. This is under the force experienced by a moving charge in a magnetic field. So question 8b. So given that the velocity we're given v is equal to 3 times 10 raised to the power 8 meter per second. Is that correct? So we're given the velocity, then, and we are given the angle to be equal to 60 degree, and we are given the force experienced F to be equal to 6.23 times 10 raised to the power minus 1 Newton. Then we are asked to calculate the magnetic flux density. So that is B. We don't know it, and given that E, which is the charge is equal to 1.6 times 10 raised to the power minus 19 coulomb. So when you get this, the next thing to do is to recall the relationship or the formula that we are going to use. So if you have understanding of the force experienced by a moving charge in a magnetic field, you will know that the force experience is given by F equal to QVB sine what? Sine theta. Is that understood? So then the next thing to do is to substitute the value. What is our F? 1.6. No, 6. Our F is 6.23 times 10 raised to the power minus 1. I hope that is understood. Then is equal to, what is our Q? So Q is the same thing as the electron here, 1.6 times 10 raised to the power minus 19. Is that correct? Good. The next thing in the formula is V. That stands for the speed, velocity, 3 times 10 raised to the power 8. Good. The next thing is what? B, which we are looking for. Then sine of the angle, that is sine what? 60 degree. I hope this is understood. So having done this, we can just simplify. Here still remain at 6.23 times 10 raised to the power minus 1 equal to, this is the one we are looking for. This is what we are looking for. This is B. This is what we are looking for here. So we can multiply this by, yes, multiply this. Oh, sorry, here is 3. Here is 3 times 10 raised to power 8. Here is the B that we are looking for, right? 3 resemble B. So here, you can just multiply this and multiply this for now and see what we have. We're going to have 1.6 exponential minus 19 multiplied by 3 exponential 8. That will give us 4 point. So I have 4.8 times 10 raised to power minus 19 minus 11. Then multiply by B that we are looking for. Then multiply by sine 60. So you press sine 60. I hope you are with me. That will give us 0.8660. So again, multiply this and this, right? So here we still have our 6.23 times 10 raised to power minus 1 is equal to, so multiply this and this, that will be multiplied by 4.8 exponential minus 11. That should give us 4.156 multiplied by 10 raised to power minus 11. Then multiply by the B that we are looking for. Is that correct? This is the B we are looking for. So the next thing is to divide both sides by 4.156 times 10 raised to power minus 11. This also 4.156 times 10 raised to power minus 11. So that this will go with this. So we'll be left with B equal to 6.23 times 10 raised to power minus 1 all over 4.156 times 10 raised to power minus 11. So then you can quickly divide this 6.23 exponential minus 1, right, divided by 4.156 exponential minus 11. So you have it to be 1.49 times 10 raised to power 10 Tesla. Is that correct? That is the unit of what? Magnetic flux density, right? Or magnetic induction. It is called flux density or magnetic induction. I hope this is understood. So this is how we tackle this type of question. Don't forget the formula. The formula is F equal to QVB sine theta. So you can as well just make B subject to the formula before you substitute. That will give us B equal to F all over QV sine theta. Understood? So don't forget the formula. So we're going to stop here today in our class and continue from here in our next class. Thank you for your time. God bless you. See you in the next class.